Hey Pre-Calc, this lesson is going to review how to graph all 6 of the trig functions. So let's just remind everybody how they start. So the sine function started at 0. It goes up and then down and then down and then up. Okay, so those were the 4 sections from the 4 quadrants. The cosecant graph, wherever the sine graph touches 0, has asymptotes. And then these are those little functions right there that are asymptotic to the asymptotes. They touch right where that sine curve has a max or a min. 2 of these parabola-looking things would be 1 period. Okay, how does cosine start? The cosine function starts, here let's just color code these for you. This was sine, this was cosine. He starts up at a maximum or a minimum if it's been reflected, and then it goes down, down, up, up. And there's the 4 sections of cosine. The secant graph is going to have asymptotes wherever cosine touches 0 because they are reciprocal functions. Wherever there's a maximum, that's where the parabola-looking piece would be touching. Okay, touching and then asymptotic. This is 1 period of secant because there's these 2 branches together and then that one. And this is 1 period of cosine. How does tangent start? Okay, tangent starts on the origin just like this. He's got 1 asymptote to the left, 1 asymptote to the right, and then he looks like an x cubed function, okay, like that. Cotangent, on the other hand, starts with an asymptote, okay. He's got asymptote, 0 asymptote, and then he goes down, down, down to the right like that. So that's a cotangent graph. So let's just summarize some things about these 6 trig functions. So how do they start? Okay, sine and cosecant, they start on 0. So sine starts with a point, which means the cosecant graph would start with the asymptote. Okay. Cosine and secant, they start either at a high or a low. A high or a low. I guess the sine starts in the middle, right? Sometimes we say middle. Tangent starts with a point. He starts with a point wherever his starting is. And cotangent starts with an asymptote. An asymptote. How do we calculate the period for these 6 graphs? Sine and cosecant is 2 pi divided by absolute value of b. Cosine secant, same thing, 2 pi divided by absolute value of the b. And tangent cotangent is just pi divided by absolute value of the b number. So they're a little shorter, right? How many sections do we divide their periods into? So for these first 4, we took the period and we divided it into 4 sections from the 4 quadrants. But tangent cotangent's a little smaller. It starts to repeat sooner, so we only divide it into 2 sections. 1, 2. Which ones have asymptotes? Which ones have asymptotes? So cosecant definitely has an asymptote, and secant. Okay, but sine and cosine are continuous. They do not have any asymptotes. And of course, tangent cotangent has lots of asymptotes as well. Which one has domain all reals? So if the domain is all reals, that means that there's no break in the graph. No break. Okay, so sine has no break in the graph, and cosine. Okay, those are sinusoids. They just continue up, down, up, down, up, down forever. There's no asymptotes, no breaks in them. All right, let's review how to graph some of these things. The first thing I notice here is that a cosecant graph is very similar to a sine graph. Okay, so the first thing we're going to do is calculate the period. And so this is the a value out in front, and then this is the b value. Okay, so the period for this guy is going to be 2 pi divided by that b value. All right, this is kind of tricky sometimes, so maybe what I'll do is go old school. 2 pi divide by 2/3, and then we'll keep change flip. So that's 2 pi times 3/2. These cancel, so the period is 3 pi. Now to help me do a better graph, I'm going to just go ahead and write down here what a section is. I'm going to take this period and I'm going to divide it by 4, and that would be 3 pi over 4. Now that's not an official math question. They would never ask for sections, but we need to know that when we draw our graph. Okay, so in terms of drawing a graph, we always want to make sure that we do at least 2 periods. So we have 3/4 plus another 3/4 would be 6 divided by 4, which is 3 pi over 2. 3/4 plus 3/4 is 6/4, plus 3 more would be 9 pi over 4. And then 12 divided by 4 is 3 pi. Does that work? Perfect. That's what it was supposed to. Okay, so we just keep adding 3/4, but we have to reduce. Right here, we're going to have negative 3 pi over 4, negative 3 pi over 2, negative 9 pi over 4. So I'm using these numbers here to help me very quickly. Negative 3 pi. All right, so I've got the x, the horizontal x's here all labeled up. Now it's time to do the y-axis, which is going to be the a value. Okay, so for sine, it would be the amplitude. Okay, so let's go ahead and mark 7/9 and negative 7/9. Okay, domain, I'm going to do that after I go ahead and draw this graph. So it's going to be very helpful for us to see y equals 7/9 sine of 2 pi, or 2/3 x. So the sine graph, does he start high, middle, or low? So sine starts in the middle. Okay, this is going to be a dotted sine graph just to help me draw the cosecant. Okay, then he goes up, then down, then up. Okay, if it helps you to draw some dotted lines right here, just to make sure that your sine graph reaches as high and low as you said it was supposed to, that helps. Over here, we're going to go down, up, down. Okay, and now we have to put the asymptotes wherever sine touches 0. So wherever we have an x-intercept for sine, that's going to make the cosecant graph undefined. Okay, again, everything so far has been dotted because we actually haven't even started drawing the cosecant yet. So wherever this sine graph touches 0, we're going to put the asymptotes. I think it's time to finally draw the cosecant graph. My cosecant graph is going to be done in pink. Wherever it has this maximum, you're going to touch right here, put a point connecting them. You can't have a break. Where this one leaves off, so cosecant graph starts. Make sure you approach these asymptotes. Okay, get closer, closer. If you draw really wide asymptotes, you're going to have to draw a wide cosecant graph. Okay, make sure you approach the asymptotes. It gets really, really close here. That so far is just one period. So I'm going to draw the second period over here on the negative side. There's half of it, and there's the other half. Perfect. I'm going to go ahead and answer these questions now about the cosecant graph. So the domain for cosecant is clearly broken up. Okay, so it's all rails except where is the first place there's no graph. So we start by looking at 0, and that is an asymptote. So there's no graph at 0, and then it's plus minus the distance to the next break. The distance from this break to that break is 3 pi over 2, 3 pi over 2n. Every 3 pi over 2 is another break. the range of this graph, okay, so this graph only has graph above 7/9 and below -7/9. So starting down here at -infinity, all the way up to -7/9 with a bracket, and then starting again at brackets 7/9 to infinity. Are there asymptotes? Yes, indeed. Okay, right where we said there was breaks. The first asymptote, x equals 0, and then the space to the next one was plus or minus 3 pi over 2n. And does this cosecant graph touch the x-axis? No, he does not touch, so there are no zeros. Let's just dash that out. All right, let's keep going. Let's review how to graph a tangent. The first thing we always start off with is the period. What is the formula for calculating period for a tangent graph? That's right, it's going to be pi divided by the b. Okay, so we've got an a value here. The b value in front of x is 5/2. Let's go ahead and write this as divide by 5/2. Keep change flip. That's going to be 2 pi over 5. Well, that's the period. What would the section be? What would the section be? If I took 2 pi over 5, and I divided that by, how many sections do we divide tangent into? Yeah, we divide him into 2 sections. Keep change flip. That's going to be 2 pi over 5 times 1/2. The 2's cancel. Okay, so a section, let's just write this down here, just a little parentheses. The section would be pi over 5. Okay, don't say 2 pi over 5 equals pi over 5. This is a different little value. This is going to help us make sure we get to that period. Okay, this does not equal that. That's half of it. So in terms of the x-axis, which is kind of the first thing we always figure out, is the period. So we're going to have 1 pi over 5 plus another 1 pi over 5. That's 2 pi over 5. That's what we wanted. Let's copy that going this way. And that guarantees that we have 2 periods. Okay, how does a tangent graph start? If you look at the y-axis, tangent graph starts with point, then asymptote, then point, then asymptote. Let's go the other way. Asymptote, point. Okay, now we do have a couple things happening here. A regular tangent graph, let's just maybe sometimes I do a little doodle. A regular tangent graph looks like x cubed, okay? But this one's got a negative. So we're going to have to reflect over which axis? That's reflect over x-axis, okay? So instead of to the right, up, right, it's going to go down, right, okay? Down, right. And it also has a vertical stretch, okay? It has a stretch, a vertical stretch by 12. Now the way that we said we're going to do that is just do a dotted regular one, and then we'll draw a stretchier one. Okay, so if this was what a reflected tangent graph looks like, down, right, okay? Sometimes people get a little confused with these halvesies. If drawing halvesies of tangent is confusing, we could always do a little extra. 1 out of 5, 2 out of 5, this would be 3 pi over 5. Okay, so maybe what I'll do is just show you what this would look like. Okay, down, right, down, right. Down, right, down, right. That does help a little bit, okay, especially with the halvesy being down there like that. Remember, as you approach an asymptote, the graph has to split like that. Okay, so I've got the correct tangents, but now we have to draw the final one, which is going to be stretchier. It's going to be taller and stretchier. So as you're looking at this, you have to make sure you're higher than this dotted one here. Higher. And then over here, okay, you're going to want to be on this side of the dotted line. not under it, okay, but farther from the x-axis, either way. Okay, stretch here on this side, stretch here on this side. Now you still have to approach the asymptote, you're just getting there quicker. Okay, stretch here on this side, stretch here on this side. They lose some of their curve when you stretch them out. Domain for tangent. All reals except, okay, there's lots of breaks. X cannot be. So you start at the y-axis. Where is the first break in the graph? Not there, so let's move to the right. The first one is at pi over 5. Pi over 5 plus or minus. Now what's the space to the next break? I notice it's 2 sections. Okay, you don't just say it's through pi over 5. The space is 2 sections. What is the space of 2 sections? 2 pi over 5. Okay, 2 sections. Not 1 out of 5, but 2 pi over 5 n. Okay, the range for tangent. The range goes from negative infinity up to positive infinity. I'll say all reals. Okay, or you could say, okay, negative infinity to positive infinity. Does he have asymptotes? Absolutely. Absolutely. The first asymptote is here, pi over 5. Okay, we just did this when we set up here where the breaks were. The next asymptote is 2 sections later, which is plus or minus 2 pi over 5n. They're very related, except domain says no graph, not equals, and asymptote says equals. Does this tangent graph touch the x-axis? Yes, it does. Okay, where? The first one is right there at 0. Plus minus, what's the space to the next 0? 2 sections again. 1 out of 5, 2 out of 5. 2 pi over 5n. Okay, let's practice writing some equations. Okay, so we're going to write the equation of the trig function. Okay, we're going to use the given information. First of all, we want to make sure that we have y equals. Okay, and they're telling us that we have to make a sine graph. So that does help a lot with the formulas for period and stuff. The sine curve formula for period. Okay, what is that usually? Okay, so the formula is 2 pi over b, and they're saying that the period is pi. I wonder what we should make the b value be. 2 divided by b to make a 1. Now we could also cross multiply here. We could put a 1, and we could cross multiply and say 2 pi equals b pi. And to calculate b, we'll divide by pi. Okay, so I think we're getting 2. The b value needs to be a 2. Okay, so b is a 2. Sometimes you can easily think about that. Sometimes you can cross multiply. Amplitude, okay, what letter does that tell us about? Yeah, the amplitude is going to be the a value. Okay, I think we're ready, okay? It's set a sine curve. We're going to put the a value out in front, 7 times the sine, and the b value is 2. So we're going to have 2x. Okay. Now let's look to make sure we did this right. Did we write a sine curve? Yes. The number out in front, that's the amplitude. That's exactly what we wanted. And if we wrote an equation like this, I would do a period calculation. I would do 2 pi divide by that b number. I'm getting pi. Is that what we wanted? Good, it checks. Next one. Let's write a cosine curve. Cosine curve, okay? The first thing we have here is the period. 2 pi divided by b is supposed to make pi over 4. 2 divided by what number makes 1 over 4? 2 divided by, I think that's supposed to be an 8. We could also cross multiply to figure this out. If we cross this way, we're getting 8 pi equals, cross this way, b pi. Don't you believe me now that the b should be an 8? Okay, so we know that the b needs to be an 8, and the amplitude, the a value, needs to be a 6. Okay, let's write a cosine curve. Y equals 6 times the cosine of 8x. Remember, your equation has to have an x and a y. Let's just double check. If the 6 was out in front, that would make the amplitude. And if we did a period calculation, I would do 2 pi divide by 8, and that's making pi over 4. Is that what it was supposed to be? Perfect. Last one, let's make a tangent equation. Tangent equation. Okay, the period is 3 pi. What's the formula for the period of a tangent graph? Yeah, it's just pi divide by b. Okay, so that's the formula, and they're telling me that they want it to be 3 pi. 3 pi over 1. All right, let's go ahead and cross multiply here. Crossing this way, we get pi, 1 pi. Crossing this way, we get 3b pi. To solve for b, I'm going to divide by a 3 and a pi. Divide by a 3 and a pi. Okay, so what is the b value equal to? 1/3. b is 1/3. The vertical stretch is 3, so that's the a value. Okay. Oh, and we also have reflection over the x-axis. Reflection over x-axis means we need to put a negative, okay, in front. All right, let's do it. Y equals, okay, we set a negative in front. The a value is 3. We're making a tangent of 1/3 x. Let's make sure we did the right thing. Negative in front would be reflection. The vertical stretch is 3. Okay, and let's just check our period real fast. The formula for tangent is pi divide by b. Pi divide by 1/3. That would make 3 pi. Perfect, it checks. Write the equation of the sine curve. Very similar to what we just did, except we're going to have to gather some information from the graph. Okay, so first of all, make sure we look at the directions. Sine graph starts at the middle. Okay, was there any reflection? Okay, no reflection. It's going up. Okay, the next thing I'm going to take a notice of is the amplitude. Okay, how high, how low? This amplitude here seems to be 2. The amplitude is 2, okay, and that would be the a value. A is 2. The next thing I'm going to do is look at the period. Let's be careful because it looks like they've got a lot of graph here. Up, down, down, up. Okay, so here's one period. Let's just take a look at this much graph. This is one period, 4 sections. The period is pi. Okay, we have to figure out a b value. The formula for sine is 2 pi divided by b, and the period ended up being just pi. What do you think this b value was to make this be a pi? Yeah, b has to be a 2. All right, let's go ahead and write this. Y equals, it's a sine curve. We've got a 2 times the sine of 2x. Let's just double check. No reflection. The sine graph should start in the middle, amplitude of 2. Okay, and then the period, let's see, the period calculation would be 2 pi over b, and that makes pi. Is that what we wanted? Absolutely, it checks. Okay, can you graph all 6 trig functions? Do you know how they start? I can write the equation of a trig function. Yes, great job, pre-calc.